अस्सलाम वालेकुम। इस सेशन में हम प्रॉब्लम 6 को सॉल्व करेंगे और प्रॉब्लम 6 में अगर आप देखें तो जो ए पार्ट है इसमें जो सोर्स दिया गया है वो -5 वोल्ट्स है। तो इस -5 वोल्ट्स की वजह से अगर हम इस सर्किट को रीड्रा करें तो इसको कुछ इस तरीके से हम रीड्रॉ कर सकते हैं कि माइनस प्लस माइनस प्लस 5 वोल्ट्स। तो डायोड similarly the resistance 2.2K। अब आप इसको आसानी से देख सकते हैं कि जैसे करंट फ्लो करेगी तो डायोड जो है वो फॉरवर्ड बाइस हो जाएगा। जैसे डायोड फॉरवर्ड बाइस हो जाएगा तो इसका मतलब है कि 0.7 वोल्ट इसके अक्रॉस ड्रॉप हो जाएगा और जो 0.7 वोल्ट इसके अक्रॉस ड्रॉप होगा रिमेनिंग जो है वो इस यहाँ ड्रॉप हो जाएगा। तो 0.7 वोल्ट 5 में से माइनस कर लीजिए तो हमारे पास जो आउटपुट वोल्टेज बनेंगे वो बनेंगे, पहले तो माइनस साइन आएगा इसका 5 माइनस 0.7 तो ये बन जाएंगे 4.3 वोल्ट्स। ओके, इसी की मदद से हम जो है वो करंट मालूम कर लेंगे और करंट का फार्मूला क्या होगा, करंट इज इक्वल टू वोल्टेज डिवाइडेड बाय द रेजिस्टेंस। ओके, सो द वोल्टेज करंट की डायरेक्शन के हिसाब से हम जो है वो आईडी, सो वोल्टेज इज 4.3 वोल्ट and divided by the resistance is 2.2। जब हम इसको सॉल्व कर लेंगे वी नीड ए कैलकुलेटर। तो 4.3 डिवाइडेड बाय 2.2 तो we get 1.595 milliamperes। So this is how we calculate the voltages and the current for this part A। अब हम पार्ट बी की तरफ जा रहे हैं। ओके, पार्ट बी में देखिए +8 वोल्ट्स एंड -6 वोल्ट्स दो वोल्टेज सोर्सेज हैं और ये दो वोल्टेज सोर्सेज जो हैं ये इनकी पोलैरिटी बता रही है कि जो सिलिकॉन डायोड है ये फॉरवर्ड बाइस हो जाएगा। ओके, अगर हम इस सर्किट को यहाँ ड्रॉ कर लें तो प्लस माइनस प्लस माइनस 8 volts, then there is a resistance output, then there is a resistance, then we have a diode, Then we have a voltage source. Okay, so this diode will get 0.7 volts across it, and here we have a ground. And there are two resistances, 1.2K and similarly 4.7K. Okay, so because of this 8 volts and this minus 6 volts, both volt source are added, and we get primarily 8 plus 6, 14 volt primarily across. Let me change the color. So from this point to this point, we have a total voltage across these 2 points is due to these 2 sources, 14 volts. Okay, now we have to find the V out voltage. And similarly the current. So V out voltage is from here to here. Now we know the voltage, potential difference across the diode, 0.7 volts. So if we take these 2 circuits, let me draw the circuit again for the new conditions. So for the new conditions, the circuit is like this. That here we have 8 volts and 6 volts, minus 0.7 volts. So if we subtract 6 minus 0.7, we get 5.3. So here we have minus 5.3 volts. So by this, we can apply a divider, a voltage divider rule, because these 2 voltages added to each other. So let's consider it 1.2K resistance, which is given, and 4.7K resistance is given. Now voltage V can be determined as 1.2K multiplied with, let me use the other tool, multiplied with, we need to add these 2 sources. So 8 plus 5 is 13.3. So we get 13.3 and divided by, we need to add both resistances, 1.2 plus 4.7. So the answer of this equation will bring us the voltage across the output. So we need to use the calculator. So by using the calculator for 1.2 multiplied with 13.3, then divided by 5.9. So 2.7 volts. So 2.7 volt is the answer. So the 2.7 volt is primarily developed across this primarily will appear at here at not. Then we can use this to find the current through this 4.7 k ohm resistance. So the current through the 4.7 k ohm resistance is the voltage sources. They should be added. So 8 minus 10 divided by the resistance 4.7 will give us the answer. We need to use the calculator. So in calculator we have to 8 plus 5.3, 8 plus 5.3, then divided by 14.4.7. So it will give us 2.83 milliamperes. So this is how we primarily determine the output voltage. We solve this circuit which is given. There is also another method in which we can use a simulator, and we use a computer simulator to solve the same circuit and then verify our results, and if there are any problems we identify those problems and fix them. So this is how when more than one DC sources appear inside a circuit, and then we primarily solve those. Moving towards the 7. Okay, in 7, as you can see, we have a silicon as well as germanium diode. So the total voltage drop across both resistances, both diode is 0.7 and 0.3 volts. 0.7 volts and similarly 0.3 volts. Germanium. So together we get a 1 volt voltage drop across this. So what we get at this point is, so at this point what we have is 11 volts. And then we apply the voltage divider rule as we have applied in the last example to find the Vout, as Vout is equal to 10 kilo ohms. Multiplied with 11 and divided by the 2 plus 10, 12k. So this will give us the value of Vout. Now moving towards here, as you can see the 10 volts and the 10 volts. So there is effectively there is no potential difference between these two terminals. So potential difference is 0 volt, causing this diode to primarily do not conduct, and so we get no potential difference across it. So the Vout becomes 0. Sorry, Vout does not become 0 volt, but the silicon diode will not conduct. Because silicon diode will not conduct, and we are taking the voltage out from here, so we can redraw the circuit, and we can redraw the circuit like this. Okay, like let me redraw it. We can redraw the circuit like this is V0, and this is the resistance, and this is the potential source, which is 10 volts. Okay, so this 10 volts will appear over here. So we get V0 as 10 volts. We can verify it by using simulator circuit that the 10 volts will primarily appear over here. There is also one thing I think I have missed. There was a application of voltage divider principle should be reconsidered because the voltage should be taken as 4.7 kilo ohms resistance. Okay, so in this circuit, what we have to do is primarily by using this current source and this resistance, we first need to determine the voltage over this primarily node. Once we determine the voltage this node, then it is easy to find out the V out. So we know that the V is equal to IR, so just multiply the current into the 2.2 kilo ohm resistance. The voltage over here, which is multiplied with 2.222. Okay, so diode will draw 0.7 volts. So after drawing 0.7 volts, we get over here 21.3 volts. Okay, so this way we get the answer in a simple manner. But we need to also maybe find the current, and this will lead us to the next part of the analysis, in which we have to consider the internal resistance of the diode and a mesh circuit as well. So we leave it. We will use the computer analysis for this kind of circuit to find out the solutions. Okay, the part B is another problem. As you can see, 20 volts and minus 20 volts will actually creates a potential difference of 40 volts. So the potential difference between these 2 points is 40 volts. So if the 0.7 volts is drop over here, then that will be less from here. So we get V naught is 39.3. Now we know the two voltages across this resistance, so we can find the current through it. So when we find the current through it, we that value will be the same as the I. So say पता चलता है कि we use the approximate model and replace it with 0.7 volts. Okay, the A part, as you can see, both diode will conduct, and for V2, V0 is very easy because gallium arsenide will draw 1.2 or 1.3 volts. So this will appear over here, and then we subtract this 1.3 volt and 0.7 volts. That will primarily develop over here. Okay, so 12 volt minus 0.7 volt, 11.3 volts will drop over. So this way, this question will be solved. Now, because the both diode has different directions, so one of the diode will not conduct, causing this circuit no current flow through this circuit. So we get both values 0 volts because no current flow. Now this leads us to the next section, in which the parallel and series parallel configurations. So in this way, as you can see, the silicon and LED is present. LED has a higher voltage across it, so it will not conduct. The only path to conduct will be this one. So the 0.7 volt will drop over here in the approximate model case, and we get the 11.3 volts over here. Similarly, because now we know the voltage, we can find the current, which is nothing but dividing the voltage by the resistance. So this way we get the current value. So moving towards the next circuit on the right side. So 20 volts and the 4 volts. So effectively causing a potential difference of 16 volt across this whole circuit. So let me causing a total potential difference of 16 volts. So our calculation should be based on 16 volts. So from 16 volts, just minus the 0.7 volt, which will drop across diode. So the rest of the voltage will drop over here, which will be 15.3 volts. So this way we calculate it, and then we calculate the current through it as well by using this resistance, because the resistance is known and the potential difference across the resistance is known. So the current is 15.3 minus 4 and divided by the value of the resistance. Okay, divided by 2.2 kilo ohms. So this way we get the current. These questions are not difficult. Okay, similarly we have problem 11, in which we can see there is a silicon diode and a LED, gallium arsenide LED. So this silicon diode will conduct, and 0.7 volt will drop across it. This I is primarily the path of I is this. So this way we have already calculated it in the previous session. Now here we have the silicon diode on both sides, and we do have a silicon over above side. And there is also a potential difference of 16 plus 4, which is 20 volts. 20 volt across. So the diode 0.7 and 0.7 will drop across this diode. So total causing 1.4 volt. 1.4 volt drop over here. And similarly, it is causing primarily a potential difference over here, which will take from, let's say, 20 volts. So 20 minus 1.4 will get 18.6 volts over here. And we can find the value of the current because current is passing through it. And similarly, we have done the same question in the last problem as well. Okay, these two questions we will do it by using the computer program, and this will be happen in the next session. Okay, next session का wait कीजिए.